In this problem, we're looking at some data for rainfall in the month of May every year for a couple years. And the first set of data is 7 years of rainfall data. And we've got 35 millimeters all the way up to 59 millimeters. And then we have one more year of data added onto this, the 8th year, which is going to be 46 millimeters in this year. And we're asked for how the addition of this last data point changes the mean, median, and mode of the prior 7 years. And it really helps if you understand what those words mean. I'm not sure how you would do this one otherwise, but it does help to know that the mean means the average, the median is the middle of the data set, and the mode is whatever number is most common. And I want to take a look at what I have here. Take a look. I've got 7 years and 8 years. Take a look at each one of these sets of numbers and see if you can find the mode. Okay, this should be the easy one right up front. Well, it's the most common number, right? So do you see any number that appears more than once? It should be 42 in this first one. That's the mode. And if you look at the second set of data, we add the number 46 to it, but that doesn't change the most common number. The mode is still 42. So you can see that the mode is not always the most useful metric, but it does have its place in data analysis sometimes. So fine, we know that the mode does not change. We can at least cross out this option, right? In this example, the mode is not changing. Well, let's take a look at the mean and the median. I've already calculated the mean of the first set of data, right? I added up all those numbers and they came out to 315 divided by 7. That made 45 was the average rainfall per year in the month of May. And the question is, how does that change with the addition of this last data point, 46? Well, 46 is greater than 45. So I don't even have to do this addition all over again. I know that's going to make the mean greater. Okay, if it were 45 again, then the mean would be unchanged. And sometimes you'll see that happen. But I know that we're going to be greater in the mean. And then the question is, well, what's happening to the median? That's the last data point here. Think about what the median means. It's the middle. So if you count your way in, this is 1, 2, 3 in from that side, and 1, 2. See, this is right in the middle here, this 42. Okay, so the median of the first set of data is 42. And if I think about the median of the second set of data, well, where's the middle? It's 8 numbers. So we have to go 1, 2, 3, and didn't want that to be a straight line. But anyway, point being, if you try to count in the middle, you actually get sort of stuck halfway in between two numbers. You're halfway in between 42 and 44. That's the middle of this set. So in that case, we use 43 as the tiebreaker. Okay, I average 42 and 44. So the median looks like it went up. In this case, we only have one option left. The mode was unchanged, the mean was greater, and the median was also greater.